Hello everyone, I'm Ate Betty. This video is all about differentiate permutation from combination of n objects taken R at a time. Let's differentiate permutation from combination.
This is the comparison chart for permutation and combination. So, let's start with the meaning. When we say permutation, it refers to the different ways of arranging of a set of objects in a sequential order or order does matter. While in combination, it refers to several ways of choosing items from a large set of objects such that their order does not matter. Next would be the order. In permutation, order, placement, and position are relevant, while in combination, order, placement, and position are irrelevant. Next, denotes. In permutation, denotes is arrangement. For example, we are arranging things, people, digits, alphabets, and colors, while in combination is selection. Combination indicates different ways of selecting menu, items, food, clothes, and subjects. So, in permutation, the order of elements is nothing but an ordered combination, while in combination, unordered sets. Combination implies unordered sets or pairing of values within a specific criteria. Next is the answers. In permutation, answers how many different arrangements can be created from a given set of objects, while in combination, it explains how many different groups can be chosen from a larger group of objects. Next is the deviation. In permutation, multiple permutation from a single combination. Many permutations can be derived from a single combination, while in combination, single combination from a single permutation. Only a single combination can be obtained from a single permutation. So the formula for permutation is P, the quantity of n and r, is equals to n factorial over n minus r factorial, where r is the size of each permutation, n is the size of the set from which elements are permuted, exclamation mark is the factorial operator, while the formula for combination is C, the quantity of n and r is equals to n factorial over n minus r factorial, r factorial. R is the number of items selected from the set, n is the number of items in set, the exclamation mark is the factorial operator. So let's come now to the example for permutation. The given problem is 10 runners join a race. In how many possible ways can they be arranged as first, second, and third? The given are the n is equals to 10 and the r is equals to 3. So here is the solutions. The formula is B, the quantity of n and r is equals to n factorial over n minus r factorial. So let's substitute. B, the n is 3 and the n is 10 and the r is 3 is equals to n factorial over 10 minus 3. So let's solve it. P, the quantity of 10 and 3 is equals to n factorial. 10 minus 3 is equals to 7 factorial. So P, the quantity of 10 and 3 is equals to 10 times 9 times 8 times 7 factorial over 7 factorial. Let's cancel the common numbers, which is the 7. So it is equals to 10 times 9 times 8 is equals to 720. So let's come now to the example for combination. The given problem is you have 7 different colors and you want to pick 2 colors for painting. How many different color combinations can you choose? The given are the n is equals to 7 and r is equals to 2. Here's the solution. The formula is C, the quantity of n and r is equals to n factorial over n minus r factorial and r factorial. Let's substitute. C, the quantity of 7 and 2 is equals to 7 factorial over 7 minus 2 factorial and 2 factorial. C, the quantity of 7 and 2 is equals to 7 factorial. 7 minus 2 is equals to 5, and copy the 2 factorial. So C, the quantity of 7 and 2 is equals to 7 times 6 times 5 over 5 factorial and 2 factorial. Let's cancel the common numbers, which is the 5. So 7 times 6 over 2 times 1. Since 6 is divisible by 2, the answer is 3. So 7 times 3 is equals to 21. Here's the examples of relating to combinations. Number 1, handshaking with other. Number 2, numbering in no particular order. Number 3, picking multiple objects in one row. Number 4, forming of a team from a number of players. And number 5, forming of a particular committee from a number of players. Here's the examples of relating to permutation. First is ranking people. Second, sequencing of draws. Third, locking with a definite sequences. Fourth, forming of words with the given letters. And 5, forming of the numbers with the given digits. So get your quiz booklet and series. Direction: solve the following permutation and combination problems and show your solution. Good luck, students!